For missing sides and angles of right triangles that are not of our special type, the 45, 45, 90, and the 30, 60, 90, we're going to have to use our trigonometric ratios to set up an equation to solve. So in this example here, we have a 35-degree angle here. So subtracting 90 minus 35, we can figure out that this angle up here is 55 degrees. So we've got the angles, now we want to get the missing sides. So we can't use the Pythagorean theorem because we don't know two of the sides. We need to know two of the sides to figure out the third side with the Pythagorean theorem. It's not a special right triangle. So I'm going to use this 35-degree angle, and this side here, 8, is opposite of that. And so to figure out what the length of, let's say, the hypotenuse is, I need to figure out, all right, which of my trigonometric ratios involves opposite and hypotenuse. So hopefully for us that rings a bell as sine. So I can say that the sine of 35 degrees is equal to opposite over hypotenuse. So in this case the opposite side is 8 and the hypotenuse is c. So now I have an equation that I can use to solve for c. Now one challenge I have is c is in the denominator here. So I want to get it out of the denominator. So I'm going to multiply both sides by c. So at this point I have c times the sine of 35 degrees equals 8. And then to get c by itself, I'm going to divide both sides by whatever the sine of 35 degrees is. And so now I'm ready to move to pushing buttons on my calculator. Again, making sure that I'm in degree mode since my angle measure is in degrees. I'm going to have c equals whatever 8 divided by the sine of 35 degrees is. And it turns out that answer is 13.9. So now that we have one of the two missing sides, we can figure out what the third side is. So we have c. Now we can figure out what b is, either by doing some more trigonometry, like what we did here, or we could use the Pythagorean theorem, because now we know two sides and we just have to figure out the third. But we'll stay with our trigonometry, and we'll stay with this angle 35 degrees. So now that I know that this is 13.9, I can go ahead and use that along with this side B. So this is adjacent to my angle A. I now know the hypotenuse is 13.9. Adjacent and hypotenuse, I can use cosine. So I can write an equation that says cosine of 35 degrees equals my adjacent side, which I don't know, b, over the hypotenuse, which I just found, which is 13.9. And so now to solve for b, the only thing I need to do is multiply both sides by that 13.9. And so now we're ready to use our calculator. So I can do 13.9 times the cosine of 35, and we find that that answer is 11.4 if we round off to the nearest tenth. And one thing that we can do to just kind of double check to make sure that these answers make sense is remember that the larger the angle of a triangle, the longer the side across from it. So C should turn out to be the longest of our three lengths. And indeed at 13.9, it's longer than B, which is 11.4, and 8, which was the given side. And then the side across from the 35-degree angle should be the shortest, since that's the smallest angle. And indeed, 8 was the given information here. That's definitely shorter than the other two. So this is a way that we can double check to make sure that our answers make sense against the picture that's been given to us. In the second example, we can see that we've been given an angle 22 degrees. So if I subtract that from 90, I can figure out what angle B is. So 90 minus 22, we're going to get 68 degrees as the measure up there. So now we're left to find the lengths of sides A and B. If I stick with the 22-degree angle, A here is going to be the side opposite of my angle, and B is going to be the side adjacent, and the side that we know is the hypotenuse. That's 18. So if I want to start off solving for A, I have opposite. I'm going to use my hypotenuse. So once again, that's sine. So I can say sine of 22 degrees equals opposite over hypotenuse, so A over 18. So to solve for A, I need to get rid of that 18. So I'm going to multiply both sides by 18. And so I just have to do 18 times the sine of 22 degrees. And so we get an answer of 6.7 when we're all done. And then to figure out the other angle, or side, so side B, again, I can go ahead and use Pythagorean theorem at this point, because once I know two of the sides, I can use the Pythagorean theorem. But if I stick with my trigonometry, I'm now looking at my adjacent, and then I can use either the opposite or the hypotenuse. So I'll stick with the hypotenuse. And so now we've got cosine of 22 degrees equals adjacent, so that's B, the side that I'm trying to figure out, over the hypotenuse, 18. So now I can multiply both sides by 18, so that clears out the 18s there. And so now I just have B equals 18 times the cosine of 22. And if we do that, we get 16.7. So if we compare that and the 6.7 answer that we got here against the angle measures, we can see that those fit. A should be the shortest side. It definitely is at 6.7. The hypotenuse should be the longest side. It definitely is at a length of 18 compared to the other two. In applications of right triangle trigonometry, we're often described an angle as being an angle of elevation or an angle of depression. And what we need to understand is that both of those angles, elevation and depression, are always made with the horizontal. So you have a horizontal side to get you started, and then for an angle of elevation, you're going to go up from there. For an angle of depression, you're going to go down from there. But we never make an angle of elevation or an angle of depression with a vertical length. It's always with the horizontal, moving up for elevation, moving down for depression. So in the example that we see below, we can see that we have an angle of elevation of 53 degrees. So that's shown here in our diagram. And then that point is 47.3 meters away. So we can see that in the diagram. So the question is, how high is this water tower under these conditions? And so if we're going to use this 53-degree angle, the side over here that we're interested in, hopefully we recognize that as being the opposite to that 53-degree angle. And then the 47.3 is not the hypotenuse because it's not across from the 90-degree angle, so it's our adjacent. And so if we go through our trigonometric ratios and think about which ones involve the opposite and adjacent, that's going to be your tangents and cotangents. So I'm going to use tangent of the angle that's given to me there, 53 degrees, is going to be equal to opposite over adjacent. So the opposite is what I don't know, so we can call that h for the height of the water tower, over the adjacent side, 47.3. So now we want to solve for h, so I'm going to multiply both sides by 47.3. So that leaves me with h times 47.3 times the tangent of 53 degrees. And so now I'm ready to move to my calculator. And so if we do 47.3 times the tangent of 53 degrees, we end up with an answer of 62.8 meters if we round off to the nearest tenth. So we've got a pretty tall water tower there. In our final example, we don't have a diagram built, but we have to interpret that information into a right triangle so that we can use our trigonometric ratios to set up an equation. So for this one, we're told that the height of the Salesforce Tower in San Francisco is 1,378 feet. So that's going to be the height of our triangle. It's going to be 1,378. And then it tells us that standing 300 feet away from the building, we want to figure out what's the angle of elevation. So if I move over this way, here's 300 feet. So the question is, which angle, if I make a triangle now, is my angle of elevation? So if you'll recall, angle of elevation and angle of depression are always made with the horizontal. So that means this is the angle that I'm interested in. So this time I know two sides of the triangle. I need to figure out what my angle is. So if we use this angle, hopefully we recognize this as being the opposite side. Here's our adjacent side. The hypotenuse is not involved. So this is another tangent question. But the difference here is I don't know what the angle is. I have tangent of theta equals opposite 1378 over adjacent 300. And so how do I solve for theta? Well, it's not tangent times theta, it's tangent of theta. So I'm not going to divide both sides by tangent, but I have to undo that tangent to get that theta by itself. So what we use, if you look on your calculator, the second function of the tangent button is a little tangent -1. And so that's the operation that we're going to use to undo the tangent. So I'm going to do the inverse tangent of both sides of my equation. So I've got the inverse tangent of both sides. So on the right-hand side, that translates into the inverse tangent of 1378 over 300. So on the left-hand side, the inverse tangent and the tangent cancel each other out. Those are inverse operations, so they undo each other. So that means I'm going to be left with just theta over here on the left-hand side. The two operations undo each other. On the other side, I'm not going to take the tangent of this ratio here. Instead, I'm going to take the inverse tangent. This is for when we know what the ratio of the sides is and we want to work back to get the angle. Usually, we know what the angle is and we're trying to figure out what the ratio of the sides is. So in this case, we have to work backwards. So on our calculator, we're going to do the second function, get to that tangent -1, that inverse tangent feature, and then enter in the ratio. And so what we find is our angle is 77.7 degrees. So we have a pretty high angle of elevation looking up to the top of the Salesforce Tower from only 300 feet away.